All right, so when you're done with Little Crab Part 10, then your little crab should look something like this. So you've got one crab, three lobsters, they're fixed, they come up in the same locations every time, in a location that's fair to the crab, so the lobsters aren't right on top of them close, and then every time the worms change positions. Okay? And then you go to run it.
Ow.
So it's even at that, it's starting with the fair positions. It's pretty tough as far as a beginner game goes. So there are some things we can do to help make the game easier to play or to give it some more extra features for things. Okay, so first of all, has anybody had any ideas for something you wanted to try as an extra feature? Okay, so we'll go in and show you some things that we can do. In first period, I already made a video that talks about doing levels and having the crabs throw rocks at the lobsters. So you can watch that video separate to see how to do that. So in this one, let's do some power-ups where we can give either the crabs or the lobsters special features. Okay, so if we had a power-up come into the world and the crab could go capture the power-up, what would be something that maybe it would be good to have the power-up do? Yeah. Okay, good. So it makes the lobsters will still move around, but if they run into the crab, it won't be able to eat it. Okay, so we're going to need to add a new subclass of actor to our world to be the power-up. So we'll call this guy PowerUp 1, since we might have more than one in the program. And we'll go pick a picture. Let's do an object. I don't know. Bombs are bad. Gold balls are good. All right, so we've got our power up. Let's put one over here. How's that size look? Kind of too big for a power up. You usually want to make those a little harder to get to. So we'll go in our power up code. If we add a constructor for our power up, then one of the things, the image class, you guys have been working with images a little bit. It has a method in it called scale. So we can get the image that the power up is using and we can scale it to a different width and height. So let's try 20 for the width and 20 for the height and see. Oops, forgot the parentheses. Now let's drag one of these guys over. How about that? Does that look good? All right. Now, when we do something like power-ups, the world class is always, that's the class that's in charge of the whole game. Okay, so we can have the world class do some stuff for us, and we can do that by giving it its own act method. So now the public class has its own act method, so now it can participate in whatever's going on in the world just like all the actors do. So, do we want power-ups to always exist in the world? No, they should show up. How often should they show up? Not very often, right? All right. So you guys already learned how to do random chances. So we can say, okay, if greenfoot dot get random number. So you figured it out in the chapter. It was like, all right, if I do get Greenfoot get random number 100, if I compare it with something less than 100, that's like doing a percent chance. Okay, so what percent of the time should power-ups show up? Something low, maybe 3%. All right, so we'll try 3%. And where should power-ups show up? Should we put them in the same place all the time or random? Random. So we've already got this code down here for doing random worm placement. So we're going to grab that and do that. All right, so now we have some code in Crab World that every act cycle, it'll create a random number. If that random number is less than 3, it'll add a power-up to the world. Okay, so let's try that.
Ow.
What are we getting for power-ups? Even at 3%, they still show up really fast, don't they? Yeah, so when we need something that's even faster or even less than like 3%, then we can increase this number from 100 to 1,000 and then have that set on 3. So now that's going to be 0.3%. So it'll just be 3 chances out of 1,000 instead of 3 chances out of 100. So now if we do that, there's 1. Okay, so now they're showing up. They're not showing up terribly fast. So that makes it fair. Now we kind of got a bunch of them, but that's okay. All right. So now we've got power-ups showing up. Now, should power-ups live forever? No, they should go away after a while. Okay, so here in the power-up code then, we can add a counter. There's lots of things in Little Crab where you're having to add counters in, so you'll see this over and over. We're going to add a counter, start it to 0, and in our act method we can add 1 to the counter each time and then put in an if statement. If counter is equal to, how many act cycles should we let a power-up live? 10's pretty short. Let's do 500. Yeah, the act cycles go by really fast. Okay, that's what you start to get an impression of with this then. Okay, so if the counter gets to 500, then we want the power-up to commit suicide. So we want it to remove itself from the world. So only the world can remove things from the world. So we have to ask the world to do something for us. Well, anytime we want to ask the crab world to do something for us, we need this little bit of code right there. Okay, that's something that wasn't in your book. That's part of why I'm showing you this, is that we need to use that to ask the world to do something, and we want to ask the world to remove an object. And if I put the word this in here, that means remove myself, remove this object that's running right now. So that is our way of getting an actor to commit suicide. All right, so let's compile that. That worked. And let's, okay, whoop, everything died. Okay, I'm going to use cheat method here. Make the lobsters disappear for now. All right, run. Where's our power up? There's one. And then is it going to disappear? There it disappeared. So that was 500 act cycles. So it's up to you then if you think if it wasn't on the screen long enough for the crab to get to it, you can make the 500 higher. If you thought it was there too long and they're too easy to get to, then make the number lower. So you just play with that for however you want. But that way they don't just keep showing up on the screen and staying around forever. Because in game design, you usually don't want your power-ups to hang around forever. Okay? All right, so now we got to let the crab have a chance to get the power-up. So we can do something similar. The crab already has behavior for looking for a worm, so we can do something similar. Let's go up here and say let's look for power up 1. And then we'll create a method, public void look for power up 1. Now notice whenever I create a new method, I always go ahead and put the left curly bracket, the right curly bracket, and an empty space in between. That way when I start filling out the inside of the method, I don't forget the other curly bracket and mess everything up. All right, so we can see like in the one above, we can use code like if I can see power up 1 dot class, then I want to eat the power up 1 dot class so that it goes away on the screen. But then after I eat it, what did we say we wanted the power up to do? Make the lobster stop for a little while. Okay, well, that means I need a way to let the lobsters know they should take a nap. Okay, take a break for a little while. Well, in Greenfoot, if you look at the structure of Greenfoot, getting actors to talk to other actors is really hard to do. Okay, it's kind of like Hollywood. Actors don't want to talk to other actors. Okay, but the world is in charge of everything, and the world knows who all the actors are, and the actors can always talk to the world. So we use the world as a go-between. All right, so we'll go back to our world, and let's create a variable in our world class, and we will call it private int lobster nap count. And then we can create a method in the world, public void start lobster nap. And we'll need another method. So start lobster nap will be the method that we let crab use to tell the world the lobsters need to take a nap. And then we need another method the lobsters will need to use to find out if they should be napping. Okay, so we'll call this other method, we'll have it be a Boolean. It'll return true or false, and we can call it should be napping. Well, the should be napping, that would be pretty easy. We can say, okay, if my, what do we call it, lobster nap count, if lobster nap count is greater than 0, return true. Yes, we should be napping. Else, if it's not greater than 0, we'll return false. No, he should not be napping. And then for the lobster nap, if the crab says, hey, it's time to start the lobster nap, then we're going to say lobster nap count is equal to how many act cycles we want to make the lobsters nap. Try the 500 again like we used. You can adjust it. So we'll make the lobster nap count 500. And then up here in the world's act method, we need to control that nap count. So we'll say, okay, if the lobster nap count is greater than 0, then we'll subtract 1 from it. So lobster nap count equals lobster nap count minus 1. So now we have all those basics in place. So let's go back to crab, and we can say, okay, crab, after we eat the power up, we want to ask the world to start the lobster nap. And then in the lobster, we've got this move method in here. And this is what we want to control. So we want to say if, and we got to ask the world and I got to go back and look it up. Crab world should be napping. Okay, if should be napping, if that's true, then I'm just going to do nothing in between the brackets. If it's not true and I shouldn't be napping, then I'm going to do the move command. So now notice we still have the look for crab here. That means if the crab runs into the lobster while it's standing still, it's still going to die. So should we also move that into this so that while it's napping you can bump into it and it won't eat you? Yeah, that sounds like a pretty good idea too. So we'll take that and put it there. So he can only move and he can only eat the crab when he's not napping. But if he should be napping, he's going to do nothing. Alrighty. Now, he might still randomly turn, but I guess that's okay. Maybe lobsters turn while they're asleep, you know, toss and turn. Alright, so moment of truth. Let's go hit the compile. See if all that worked. It does. Run. Live long enough to get a power up. There it is. There it is. It's working. And now we're getting lots more power-ups. So every time I hit a power-up, the lobsters nap some more. Alright, now just go sit in the corner. And there they woke up from their nap and they started running around again. Okay? So that's one way you can do a power-up that controls something that goes on in the game. What other types of things might you be able to control temporarily with a power-up like that that would help? Slow down the crab? You could slow down the lobsters. Yeah. So instead of, if you look at the lobster, then instead of when it's napping, making it completely skip the move method, you could set up some similar methods like that and have the move method inside a count so that the lobster only moves every second act cycle or every third act cycle. So you could temporarily slow them down that way. Okay? Would the crab being faster help? It could. Depends on how good you are at controlling it. So if you look at the crab code, you could do the same type of thing, introduce another power up, set up some variables in the world to go along with the power up, and then in the crab code, here where the crab is doing a move, you could do an if statement like we did the if should be napping. You could do if crab is faster, and when the crab is faster, do 2 move methods instead of just 1 move method. That would make the crab move twice as fast. So you could go do something like that. All right. Now, those are good power-ups. Can you also have bad power-ups? I guess they'd be power downs or traps or something. Yeah, you could have things like that. So we had that little bomb animation thing. You could make bombs show up randomly and hang around for a little time, and if the crab runs into the bomb, then the crab dies. You could do that. There's also another kind of interesting thing is the worms just kind of sit there. Okay, so you could do some things with the worms for extra features. An easy thing to do with those, if we look at the Q drive, go to Career Tech, CSP, green, oh no, it was in CSP. Here's a second picture of a worm, which is just the worm mirror image. So if we take that guy, and I'm right clicking, I know you guys can't right click, copy it. I'm going to go to in my image folder and paste it in. Now I have 2 images of the worm. I can borrow from the crab code. We had images for the crab, so we can do the same thing. We can do 2 different images for the worm. And if I initialize my images, worm and worm 2, and then I can make the worm wiggle. Oh, whoops, did something wrong. Ooh, what'd I do wrong? I created a method, but then what did I forget to do with that method? Forgot to put it in the act method so that it would actually use it. There. Now the worms are wiggling. Okay, same thing. It's kind of a fast wiggle. You could do the image counting thing to do that. Another interesting thing to do with the worm is, what if the worms were harder to catch? What would make the worms harder to catch? Greenfoot, get random number 100 less than 2. So what if 2% of the time the worms just moved? We look at the Greenfoot documentation under actor. We can see that one of the things actors can do is to set their location to a X and Y coordinate so they can change where they are instead of moving. So we could go in the worm and say, okay, 2% of the time, let's set my location to a different X and Y.
Ow.
I got to use the cheat method. That makes it a little harder, doesn't it? Just as you get to them, they move out of the way. All right, so that's another thing you can do with the worms. Some other things you could do with you could make another subclass of the worm. And call it a poison worm. And then in your crab code, you could change the, where is it in the crab code? So in the look for worm part here, you've got if can see worm, eat worm. Well, you could add something ahead of that that said if can see poison worm, then put something in there to, you know, make the crab stop for a while because it got sick, or you could make the game end because it ate a poison worm and died. So you've got some other features that you can do with that as well. Okay. Let's see. Any other? Okay, another thing you can do with the worms is to make a worm that will call its lobster friends into the world. So we will do another new class of worms, and we'll call this one a lobster worm. So because we made it a subclass, he'll still do everything the normal worm does. But in our act method, we'll tell him to super.act so that does everything the regular worm does. And then we're going to tell the worm that, well, if I can see a crab, so if the crab comes and tries to eat me, then instead of doing anything bad to the crab, I'm going to ask the world to add an object, and the object I'm going to add is a new lobster, and I'm going to put it at some random coordinates. So now we'll compile that worm, and we need to put one of those in the world so we know it exists, and so that we can test it, I'm going to put it at a particular location up in the left-hand corner so we can go eat that worm and see if it happens. So compile everything, and just to make sure, we'll take all the existing lobsters off. And let's see, is this guy... Okay, he is a lobster worm, so we know he's the one. And, oh, he moved. So, there.
Ow.
And you can see we'd have to refine that just a little bit, because in that brief time that the crab was next to the worm, it executed that code so quickly it actually generated 1, 2, 3, 4, 5, 6, 7 lobsters instead of just one. So we would need some type of control on that code so it doesn't generate a whole bunch of lobsters, but it just does one. Alright, so there's some little crab extension ideas based on power-ups, based on changing worm behavior, making some evil worms, worms that are harder to catch, and using Crab World to have variables in Crab World, and having an act method in Crab World so that the world can participate in the action going on, and creating methods in Crab World that the actors can use to communicate through the world in order to affect each other.